Let's talk about chain rule. The chain rule is used to find the derivative of composite functions. For example, when we have y equal to f of g of x, then the derivative of y, it would be the derivative of the outer function, which is f prime g of x, multiplied with the derivative of the inside function, which is g prime of x. Let's do some examples. For the first one, we have y equal to the sine 3x squared plus 2x. So here we have the outer function, which is the sine function, and the inner function, which is 3x squared plus 2x. So if we find the derivative using chain rule, first we have to differentiate the outer function. So we'll get the cosine of 3x squared plus 2x. When we differentiate sine, we get cosine. And then we have to find the derivative of the inside function and multiply it. So the derivative of the inside function, 3x squared plus 2x. All right. So for this step, when we differentiate 3x squared plus 2x, we'll get, when we differentiate 3x squared, we have to put the power in front, so we get 6, and then subtract 1 from the power, so we'll get 6x. The same thing applies to 2x here, so we get 6x plus 2. This will be the answer. Let's move to the next question. This time, we have to find the derivative of y equal to cosine the square root of 3x plus 1. Again, we have to use the chain rule. So here, the outer function is the cosine function. So when we differentiate the cosine, we get negative sign. And then we have to differentiate the inside function, which is the square root of 3x plus 1. If we differentiate this part, then again, we have the composite function again, which is the square root function, and the inside function, which is 3x plus 1. So first, let's deal with the outside function. So if we differentiate the square root, we get 1 over 2, the square root of 3x plus 1. Because this thing has the power 1 by 2, we subtract 1 from the power. So the power is like negative 1 by 2, so we just put it in the denominator. And then we have to deal with the inner function, which is 3x plus 1. If we differentiate 3x plus 1, we'll just get 3. So if we clean it up, we have this thing will go into 3. So if we clean this up, we get negative 3 over 2, 1 over the square root of 3x plus 1 sine the square root of 3x plus 1. That's it. We can move to the next one now. This time, we have two variables of x, like e to the power x squared, and then cosine of 2x. So for this one, we also have to use the product rule in addition to the chain rule like before. So if we differentiate this, we need to apply the product rule. So the derivative of e to the x squared multiply with the cosine 2x plus e to the x squared multiply with the derivative of the cosine of 2x. For this one, let's do separate parts. If we differentiate e to the x squared, we have to deal with the outer function, which is the e power function, and then the inner function, which is x squared. So let's deal with the outer function first. When we differentiate e function, then we get the same thing. And then we have the inner function, which is the power of e. So we have to differentiate a squared here. Then we'll get e to the a squared times 2x. Okay, only one left. Let's differentiate the cosine of 2x. Again, this has the outer function, which is the cosine function, and the inner function, which is 2x. If we differentiate cosine, we'll get negative sine. Then we have to differentiate the inner function, which is 2x. So we'll get, when we differentiate 2x, we get 2. So negative 2 sine 2x. We can just rewrite all these parts in our orthogonal expression. So in the final, we will get like 2x times e to the x squared cosine of 2x plus, oh sorry, minus here, minus e to the x squared sine 2x. Okay, that's all. Thanks for watching.